Hey guys, Dr. Brown here with Kubo Math, and tonight we're looking at the integral of cosecant to the n. Okay, we're the integral of cosecant to the n x dx. Recall the other videos we've looked at sine, cosine, tangent, now secant, cosecant, and we've raised those to the second power, third power, and then we went back and did each of those to the nth power and compared the formulation we ended up with on the nth power when we let n equal 2 and 3 and compared that to our previous results when we just performed the integral of cosine squared, say, or tangent squared. So we've performed these, so you might look for the video of cosecant to the second power, cosecant to the third power, and I have the results over here of those we'll pan over in a moment. But now we're going to do cosecant raised to the nth power, that integral. Now I'm rewriting that instead of cosecant to the n x dx, I'm rewriting that as cosecant x parentheses raised to the n, which is the same as this. It's just, to me, this is more obvious, okay? All right, so let's get rolling here. All right, let's take this and break it into two pieces so that we can use integration by parts. So if we take the cosecant x n minus 2 times cosecant x squared, n minus 2 plus 2 is just to the n. So I end up with the exact same as we have up here. Now then, I know I can integrate cosecant x squared, cosecant squared x, however you want to say that. And I know I can differentiate that. So let's get over here and see if I have enough cord. And di plus minus, and we're going to integrate cosecant x squared. Can you see that? Is that just about over too far, aren't I? Let me just pan over a little bit. There's several formulas over there we'll see in a moment. All right, now we have over here that we're going to differentiate cosecant x to the n minus 2. Okay, all right, let's differentiate this. We bring down the n minus 2 times what's on the inside, which is cosecant x to the n minus 2 minus 1, which would be n minus 3, times the derivative of what's on the inside, which is minus cotangent x cosecant x. Okay, now then, let's integrate this, which is just minus cotangent x. We did that one in a previous video. Now then, we have the cross product of that. So I'm going to just bring down this integral here. Cosecant x to the n, I'll bring this one down, dx equals minus cotangent x cosecant x to the n minus 2. Now we're going to integrate this row. I have a negative times a negative is a positive times a negative is a negative. So minus n minus 2 is a constant. We'll put it on the outside. The integral of, I'll keep the same, I'll keep my cotangent term first. So I have cotangent x times cotangent x. So cotangent x squared. And now I have cosecant x times cosecant, well, that's cosecant x to the n minus 3 times cosecant x to the first. So n minus 3 plus 1 is n minus 2. So I have cosecant x to the n minus 2. Did I get all the terms? Cosecant squared, cotangent squared cosecant to the n minus 2 dx, and the n minus 2 is on the outside. Okay, we have everything. Now then, there's an identity out there. Cotangent, I'll write it this way for the moment, equals cosecant squared x minus 1. I'm going to replace this cotangent x squared, which is this term, with cosecant squared x minus 1. And we'll just work with this integral for a moment, and then we'll catch everything up here soon. So I have n minus 2 times the integral of cosecant x, I'll keep the same nomenclature I'm using here, squared to the outside minus 1, that's in brackets here, times cosecant x to the n minus 2 dx. Now then, I need to distribute this cosecant x to the inside. So I have minus, and I'm actually going to break it into two integrals. Minus n minus 2, the parentheses of n minus 2, times the integral of cosecant x squared times cosecant x to the n minus 2. So I have n minus 2 plus 2, which gives me cosecant x to the n dx. Oh, you can already see what's going to happen here. All right, now then, I have a negative times a negative, which gives me plus n minus 2 times the integral of cosecant x to the n minus 2 times 1. Cosecant x to the n minus 2 dx. Alright, so let's catch everything else back up here. I have, we'll just go here, the integral of cosecant x to the n dx equals minus cotangent x cosecant x to the n minus 2 minus all this other we just did. Now you'll notice we have the cosecant x to the n here, that integral, and we have the same thing here. So I can add n minus 2 integral of cosecant x to the n dx. I can add that one and add it here also. So here I have one of them, right? So I have 1 plus n minus 2 gives me what? n minus 1. So let me go ahead and write it here. N minus 2 integral of cosecant x to the n dx. Alright, so I end up with n minus 1, the integral of cosecant x to the n dx equals minus cotangent x cosecant x to the n minus 2 plus n minus 2, the integral of cosecant x to the n minus 2 dx. Okay, I don't want to know, and that's pretty sloppy, what n minus 1 times the integral of cosecant x to the n is. I want to know just what one of them is. So I'm going to multiply this by 1 over n minus 1. And if I do that on this side, keep that negative here, 1 over n minus 1. And I'll just put that one n minus 1 there. Alright, so this cancels out, and I'm going to end up with the integral of cosecant x, I'll go ahead and put my n back here now, dx equals minus 1 over n minus 1. I'll tell you what, I'm going to leave it outside. 1 over n minus 1 and that's a negative, cotangent x cosecant x to the n minus 2 plus n minus 2 over n minus 1, the integral of cosecant x to the n minus 2 dx. Now you may be thinking, well, I don't know if that's correct or not. All right, I'm going to pan this around. Okay, now you can see here at the bottom the integral of cosecant squared x is minus cotangent x. And we'll get to cosecant cubed in just a moment. Okay, so if I let n equal 2, now I'm off the screen, but that's okay. I've been told I look 70 years old, so maybe if me off the screen is better. All right, so if I let n equal 2, 2 minus 1 is 1. So I have minus 1 times cotangent x, and then cosecant to the, n is 2 here. Let me write that down. N equals 2. That's what we're looking at. N equals 2. So 1 over 2 minus 1, it gives me a negative 1 times cotangent x. 2 minus 2 is 0. Anything to the 0 is what? It's 1. So that's just times 1 plus 2 minus 2 is 0. Well, 0 times anything is 0. So I end up, when n equal 2, with minus cotangent x, which is exactly what we ended up with. If you integrate cosecant squared x, you get minus cotangent x. That's why we used it here. Okay, now then, let's let n equal 3. So now n equals 3. So now I have minus 1 over 3 minus 1. So that's minus 1/2 cotangent x. 3 minus 1, or excuse me, 3 minus 2 is 1. So cosecant x plus 3 minus 2 is 1. So I have 1 over 3 minus 1 is 2. The integral of 3 minus 2, which is the integral of cosecant x. Now you'll notice I put this here, the integral of cosecant x. If you work through that, it's the natural log of cosecant x minus cotangent x. So I have 1/2 the natural log of cosecant x minus cotangent x plus c. Oh, you'll have to zoom in, I guess, to see that. So what did I end up with when we integrated cosecant cubed? 1/2 cotangent x cosecant x. That's a negative right here. Negative 1/2 cotangent x cosecant x plus 1/2 natural log of the absolute value of cosecant x minus cotangent x plus c. So that formulation for the integral of cosecant to the n dx is correct. That would be it right there. Well, I guess the formulation is up above it, isn't it? Oh, plus c. Wow. All right, so that's it right here. That is terrible. Okay, I guess now we'll move on to another trig function, and we'll do this again and keep rolling. I think in previous videos we've performed the integration on secant secant and secant cubed. I don't recall performing secant squared, but maybe I just go through the same exercise with secant squared, secant cubed, maybe secant, secant squared, secant cubed, secant to the n. Of course, when you do the n formulation, it's equal or greater than 2. So 2 is the smallest, but I can do all three because we'll be needing this integral, because we'll end up with something very similar to this if we do secant. All right, so stay tuned for that. Look back through the videos where we've gone through the same exercise with sine, cosine, tangent, and now cosecant. We'll do secant next and keep rolling. All right, guys, why are we doing this? Together we're trying to build a better tomorrow and do that through math. That's all for now. We'll talk to you next time. Thanks.